Welcome back to another exciting chemistry lesson. In this lesson, we are going to look at how to write net ionic equation. This term net is basically the term for overall. So this net ionic equation only shows the species, more specifically chemicals, okay? So we are looking at another word for chemicals that involve in a reaction, usually forming a solid. It could be a gas, or it could be a specific liquid as well. So it will tell you in the situation that describes a chemical reaction. Now, what about other ions that are in the solution or in the mixture that are not involved in the reaction, which forming a solid, a gas, or a liquid? Well, those ions are considered as spectator ions. That is, they do not participate in the reaction, but it is in the mixture, okay? So they remain as aqueous ions in the solution. So before we look at specific sample, again, we have the solubility rules that tell us which chemicals are soluble, which are insoluble. Insoluble, basically, they would form a precipitate. And we learned from the previous lesson in a double replacement reaction, a reaction only occurs when there is a precipitate form, and in some cases we have water form or a weak acid or base form, and in other cases we will have gaseous form. In this last two situations, it would tell you in the description, where in here, the first situation, the precipitate, we kind of have to apply the solubility rules from there to determine if it is going to be a chemical reaction, and we are going to show that right now. So let's look at this example right here. We have lead nitrate mixed with potassium iodide. Right now we know that nitrate is this right here. It is always soluble, and of course potassium iodide, this is soluble as always. So what does that really tell you? Well, if it's soluble, it's gonna break down into ions, and I'm gonna write right here. First of all, we need to know how to write the ions for each atoms or polyatomic ions from the chemical formula. So I know nitrate is NO3 minus, and lead is, well, in this case, if this NO3 minus, and there's two of them, so lead must be 2 plus, right? Because the net charge needs to be equal to 0. And you start working off with what you know, because we don't have a rule for lead using a periodic table. And here we have potassium. That's pretty easy, group 1A. And iodide, which is group 7A, so that's easy. So we are going to go back to the ideas of a double replacement. They switch the cations or anions to form new compound. So in this case, I'm just going to switch the anions. And if that's the case, look what happened. I would have Pb 2 plus. For now, I'm just going to write out with the charges, okay? And iodide minus. And over here, I would have potassium plus and NO3 minus. And if we look at this right here, we don't have a solubility rules for lead and iodide, specifically in terms of that's being soluble, but we have one right here. For group 7A, it is always soluble with the exception of lead. So therefore, here we have the exception. So this is going to be insoluble. Okay, I'm just going to abbreviate that. But for potassium and nitrate, we have nitrate and potassium. So this one is soluble. So this two ions is going to exist as spectator ions, okay? So what we have here is this. We have this going to form a solid. So how does that work? Well, we have to write a chemical formula for that. Remember the crisscross methods? So what we do is we have to do the crisscross. So we crisscross right here, right? Well, that's a 1 right there. So that means we only have one lead, okay? Because the number 1's in front of the minus charge. And over here we have a 2, so we crisscross. That tells you there are 2 of the iodide. There you go. That's a crisscross method. Now go back to determine what reactants is involved in making this solid. So this is going to be a solid precipitate because the word insoluble. Now going back, which we have to write in terms of ions that are involved in making this. Well, first of all, we are going to get used to the format of writing the positive first. So we have lead, okay? So we have Pb, what's the charge for lead? 2 plus right there. And of course, this is going to be initially, it's going to be in aqueous form. Remember, this is soluble, okay? And then adding to what? Iodide. So if we have iodide right here, I minus. But how many do we have? We have 2 of them. So we have 2 right there. And the state of matter is aqueous. So that's how we write the net ionic equation given our 2 solution with 2 separate compounds that are soluble initially. Okay? And of course, if one of them is insoluble, you would not have a reaction. So we're going to do a few more problems, okay? Now let's do another problem. Here we have silver nitrate and potassium chloride again. And again, start writing out what you know. So we know that nitrate is always soluble. So we know that nitrate is NO3 minus. Now you know why you have to memorize those polyatomic ions. Because we don't have a rule for silver. But if this is minus, this must be plus 1 because we only have 1 nitrate. And over here we have potassium plus and Cl minus. And we are going to switch the anions, okay? So that's the case. We have what? We have silver plus chloride minus. And then we switch over here. So we have potassium plus and NO3 minus right there. And we have the rules for group 1 and nitrate. So this one is soluble. So therefore, this is going to be spectator ions. I'm going to put SP right there. Okay, spectator ions, okay? So it's going to remain as ions in this mixture. Over here, we have silver chloride. Silver chloride is what? Well, silver is right here. But we are going to look at chloride. That's group 7A. And again, silver is one of the exceptions. So this one is insoluble. So we are going to have that as a solid, okay? So go backward again. If this is insoluble, what product are we going to make? Well, think about this. We have, oh, look, plus 1 and minus 1, they cancel out. So we don't have to do the crisscross. So we have silver chloride. There you go. And going back, this is your solid. And going back to determine what reactant are used to form the solid, or specifically what ions are used to form the solid. Well, of course, we have silver plus, and this is going to be in aqueous ions. And then we have Cl minus. And how many Cl do we have? We just have 1, so we don't have to worry about anything else. So this is also aqueous ions as well. Isn't that nice? Well, on your answer key, when you type this on Streamline Ed, you don't have to put in the state of matter because that's too many information. But when you write paper or show work on your test, write the state of matter to show that you understand this is initially aqueous ions that react or combine together to make this chemical bond to form that solid. Let's do a few more examples. Let's do this one right here. In this case, we have mercury, and notice how mercury right here exists as a diatomic ions, okay? Basically, it's stable at Hg2 instead of Hg, okay? So we have to remember that when we work with mercury. That is very important right there, and sometimes that can be very tricky as well. So in this case, we have Hg2. What's the charge for it? I don't really know. But I know that NO3 is minus, and there are 2 of them, so this must be 2 plus. Isn't that nice? So now we go to the next one, calcium. That's pretty easy. 2 plus, that's from group 2A, and chloride is minus. And we are going to switch. Okay, there you go. And if we switch, what we have here is we have silver 2 plus, right? And then we have that combined with chloride. Notice I haven't tried to balance out yet. I'm going to do that later. Is this soluble? It is insoluble based on this group 7A with exception right there. So this one is insoluble. Yes. So we have our precipitate. So therefore going to be a reaction. And then we have the other one where we have calcium chloride, which combined with NO3 minus. And right away, anything with NO3 minus is soluble. So this one is soluble. So this 2 ions going to be spectator ions. Now let's go backward and look at this. What is the chemical formula solid that we are going to make? So let's do the crisscross methods. So here we have what? We have 1 in front. So therefore we only have 1 Hg2, which is mercury. And over here we have a 2. So therefore we're going to have Cl2. And this is going to be a solid. So let's go back and write our ions that we are going to use to make this product. So in this case, we have Hg2+, which is coming directly from there. That's pretty easy, right? Because we only have one of it. And then we're missing a 2 right there. And then for chloride, it's going to be, of course, this is going to be aqueous solution. And Cl, but Cl, in this case, how many Cl do we have? We have 2 right there, right? So we put a 2 there. So what state of matter is going to be? Aqueous. And that's all you have to do, okay? Isn't that easy? Now let's look at this situation before we go back to the other one. In this case, we don't have a net ionic equation, but it's giving us a situation where we have HCl, hydrochloric acid, react with sodium sulfide and produce this gas, right? When we produce a gas, the gas is going to escape, okay? So therefore, we have to have a chemical reaction. So what we have in this case is we have HCl, okay, react with Na2S or sodium sulfide. So the same basic rules apply. We have H plus Cl minus, okay? And then we have Na plus and S2 minus. So if that's the case, we just do the same basic strategy, okay? So we have H plus and S2 minus. And here we have Na plus and Cl minus. We know this is going to be soluble, okay? So this is soluble. Based on group 1A, everything in group 1A is soluble. But this one is where it gets tricky because this one is forming a gas. So let's look at this. How is this going to look? Well, we know this is going to be a gas because it tells us in the problem. So let's write the product for this. So what we have here, I'm going to write down here. So we have H plus, S2 minus, and we do the crisscross method. So we have H2 and S. There you go. And this is a gas. So that's pretty much it. And now we go back and determine our reactants. What's in our reactants? So we have H plus. And how many H plus do we have? Well, there's 2. So we have 2 right there. What's the state of matter? Aqueous. And then for sulfide, we just have S2 minus. And of course, aqueous. How many sulfide do we have? Just 1. So we are pretty much done. Isn't that nice? So in this case, we have the problem tell us that there is going to be a reaction and why it is because we're forming a gas. Now let's try this one particular problem together, and this is the last one. So we have, in this case, we have K plus and OH minus, okay? And here we have Fe. What's the charge for? I don't know, but we know this. We know NO3 is minus, and there are 3 of them, so this must be 3 plus. And we are going to switch our anions. So in this case, what we have here is, and after we switch, we have K plus NO3 minus. Well, both of them are soluble, right? So this one is soluble. They're going to exist as spectator ions. But right here, what we have here is Fe3 plus and OH minus. We don't have a rule for that. So this one is insoluble, okay? So let's write our product for this. So in this case, what we have here, we're going to have to do the crisscross. So for hydroxide, which is OH minus, we bring down here, we have just 1 Fe. But for here, we have 3, but this is a polyatomic ion, so we have to group them together. It wouldn't make sense if I have that. That is not the same thing as this, okay? 2 different things. Here we have 3H, but 1 O. Here we have 3O, 3H. So that's why we use parentheses. Now let's go back and write our ions. So we first of all, we have Fe, okay, 3 plus, and this exists as aqueous ions. And then we have OH. There you go, easy. But here, how many OH do we have? We have 3, so we had to put 3 there. So there you go. And this is our net ionic equation. So again, the key part to working with the net ionic equation is be patient and write out all the work and start off from there. Don't get tricked by a lot of writing. Just start off with what you know and work from there. And by applying the solubility rules and go backward from your solid. And as always, if you have any questions, take a picture of your work, put it in the forum, and we will help you from there. And we'll see you next time on another exciting chemistry lesson.